Okay, let us start. Already. Hey, so welcome everyone. My name is Marek Bubala. I'm a senior engineer at Goldman Sachs for over 3 years now. I am a tech lead of Decision Services platform. This is a platform that is developed inside company to automate the execution of decision models that automate daily operational decisions within the company. So what we are going to talk today about is I'm going to give you an introduction to Java Flight Recorder, and then I will talk about how this tool can be used to uplift your non-functional testing. We are going to focus on performance testing, but non-functional testing in broader scope as well. So let us start with a little survey that will allow me to answer the question if the statement on the slide is correct or not. So those of you who execute performance tests as part of your every release of your product, please raise your hand. All right, so I would say like 20% of an audience. And then the second question would be if this performance testing is actually automated from the moment when you actually prepare a target environment that you use for testing to the moment where you verify the results. If this is fully automated, please raise your hand. All right, not bad, like 5%. So this actually confirms what is written on the slide. What you have here is a patent claim raised by Hewlett 7 years ago to have performance tests included in a continuous delivery pipeline. This is actually this was triggered because they thought no one is doing it. Why don't we raise a patent? And they actually got one. So we know that right now, looking at your responses, that it is very rare to have performance tests automated in your CD pipeline. It is actually not often to have it automated outside as well. And it's not considered part of mature continuous integration for whatever reason. But let us think about why this is the case. So if you look at unit testing, right, there are certain properties of unit tests that one would expect to find in the unit test battery. And these properties allow you to basically maintain your test battery a little effort. And whenever you don't see these properties there with your unit, then you actually treat it as a tech debt. So we expect to have unit tests fast and so we have builds moderately quickly, and we expect them to be isolated. So the sequence of how we execute tests shouldn't interfere the results. And then they should be repeatable and self-validating, where self-validating means that we can usually have an assertion, and with these assertions we can validate that everything from functional standpoint is how we expect it to be. Well, the thing is not that easy, not that obvious when it comes to integration tests, and it gets even more complex performance tests. And why this is? Well, mainly because none of these properties is actually fulfilled by performance tests. We can try to build it in a way that we will meet some of these criteria, but it's really hard. So first of all, your performance tests are by definition going to take some time. So you will have test execution, for example, for load or stress testing, that will basically take time. And if they fail, what this means, it usually means that you have to execute your battery one more time, and this actually costs you time. It costs you in terms of headcount, because you have to maintain these tests and you have to change them very often. But from this table, the most important problem with performance tests, at least in my opinion, is how they are validated. It's very hard to properly validate performance tests. And why is this the reason? Mainly because of what is the result of performance tests execution, right? So if you think about the full execution of performance, you will end up with reports with data, and it to be a large set of data, very likely. And in addition to this, so you are going to have a large quantity of data. In addition to this, you will not have, probably you will not have a common API to access this data or analyze it. So you will end up, for example, with some kind of reports with metrics that someone has to look into, and it's usually a human, and it's usually not your junior developer. Be someone who is familiar with the product, is going to be someone who is familiar with the domain and how your product is deployed. So this is so-called test oracle problem, where in the simplest and most desired form, we would like to have every test validated in automatic manner with clearly specified assertion. But in case of performance tests, it's not always the case. It's usually actually completely opposite. So let us think if there are any improvements in Java 11 that can help us with this problem. We obviously can't solve it, but we can improve or uplift our tests, and this is what I am going to talk about today. So with a release of Java 11, there were certain changes made in how new versions of Java are going to be released. So you are probably familiar that now we are going to have 6 months release cycle, and in order to make it easier to release every 6 months, OpenJDK and Oracle JDK, in terms of in functional sense, they are basically the same right now. And so what it also means is that JFR, which was a commercial add-on, Java Flight Recorder, which was commercial add-on together with Java Mission Control, Java Flight Recorder got into OpenJDK, and it was opened. So it was open sourced. Java Mission Control, from this point of view, was actually taken out of JDK. If you used Java Mission Control before, you are probably aware that it was to be found under Java Home bin. Right now it's no longer there. It is actually in GitHub, and you can use it basically by providing dependencies to the libraries and use it. So what I'm going to talk about Java Flight Recorder. Then we will move to Java Mission Control, and in the end, I am going to focus on a use case that is based on the Decision Services platform, so the project that I'm working in at Goldman, and I will show you, in this use case, I will show you how we actually incorporated these products to uplift our non-functional tests. All right, so let's start with an introduction to Java Flight Recorder, what this actually is. This is a tool that runs within your Java application, and it collects information from different subsystems of JVM. It can collect information that are basically already there, but it actually can collect them into one place and make them available to you. By default, JFR is stopped, so it doesn't cost you anything, it doesn't work. But then you can start it, either from inside your application or remotely using JCMD or JMX or Java Mission Control for this example. And when you start it, you have to say what events of JVM you are interested in. So there is a certain configuration file. There are some prepared configuration files that are coming already with JDK. And what you will find inside is a set of configuration criteria that is defining what is to be recorded and how often. And so there is a certain trade-off in terms of what you will record and how much resources this is going to cost you. So by default, the profiles that you are using that are already there for you, default and profile, will cost you between 1% to 2% of your resources. So we treat it as a negligible, but if you decide to build your custom configuration with very detailed recording settings and very dense frequency of recording, this can actually be more. So it makes sense to test on your application how much this actually costs you. And then when you start the JFR, you provide this configuration. JFR will start to collect all these events and build a sequence of these events in an output file. The output recording file, the binary file that is produced when you stop the recording, is going to contain a sequence of recorded events, and then you can download the file locally to your client, either remotely or you can leave it on the server side. It's actually both functionalities are supported. So how is this done internally? You will find two modules in Java API that are related to JFR. The first one, the one in the bottom, is JDK Management JFR. This is a module that allows you to control your application, your JFR instance remotely. So you can start, stop, and provide the configuration, what we discussed a minute ago. And then there is a main module, JDK JFR. This one coming with two packages, JDK JFR that allows you to interfere with flight recorder from your application. We'll see how we can do it in a minute. And then the second one that allows you to consume the recordings. So everything that you need on client side when you actually are facing the recording and trying to do something with it. But the most important concept within the whole Java Flight Recorder is the concept of event. So everything in Java Flight Recorder is an event. And recording, as I mentioned before, is going to be a sequence of such events. And how is event defined? So each event will have its category. It will have an ID, name, and description. You can see, for example, this is a very simple event that occurs in a certain moment in time and carries a payload with basic information about CPU utilization on the host that is running the application. So the payload that you see here is fairly simple, but there is no limitation in terms of how complex or how nested the hierarchy of the payload can be. It actually, there are events that are, well, way more complicated than this one. What is important from this slide is that base JDK already comes with a set of events that are available to you. And these events allow you to monitor what is happening inside your Java application in terms of threads and what's happening with them, like start, stop, and monitoring of threads. Then we have information about I/O, whether this is network or file, information that occur. And then CPU, memory monitoring, GC monitoring. There are actually over 130 events right now that are available in current configuration options that you can either enable, disable, and use for your testing. And then, if this is not enough, then there is a way. There is a way to actually, sorry, it's too far, to actually extend, to actually define your own events. You do it by extending an event from JDK JFR. You annotate it with JFR annotations, and you can define an entirety that you will record, and it's going to be available later in the recording file. All right. So when we have the recording file that we created with the tool, how do we analyze it? What can we do with it? So JFR, starting from version 9, the JDK version 9, and now completely free, provides you with an API, with consumer API that you can do the analysis of the recording file. So what you see is you only point to the file, you parse the results in, well, DOM manner, so to say, and then you end up with a list of recorded event. And it's, well, recorded event is basically all you need to do analysis later. It is very generic structure, generic Java type that represents all event types that are recorded. So, I mean, each instance is an event, but you can have different event types. It's going to give you, provide you with getter methods to common properties that are defined in every event, like start time, duration, if there is a duration, ID, name, category. This information you can get simply with getters. So with the use of Java Streaming API plus basic API provided by JFR, you can actually create very powerful expressions. And then because payloads differ between event types, like the payload of thread start event is going to be completely different from the payload of for example, memory monitoring, you have to access these payload details with the free-form strings. There is no dictionaries provided. So what you see, the first example is assuming we have this CPU load event, how you can build the statistics of JVM user CPU usage, right? So you basically have you start with a list of recorded events, which is your full recording, and then you filter by event type, CPU load, you get JVM user, you add it to some kind of structure that will provide you with statistics. In this case, this is Commons Math, but, well, you are free to use whatever you want. So you see there is a slight inconvenience in terms of how you can access these payloads. You have to know prior the execution what properties you should expect inside this event. This is, well, inconvenient, but then we are going to show what we can do with it. So right, with this headless analysis, headless API, we are able to build flexible heuristics. We are able to apply assertions on top of it, and easily build assertions that are checking what is your CPU utilization or memory consumption, what is, we can use statistics to do it. And then there are two additional features of recordings that are, well, less obvious. First one is, since it is recording of what was happening in your application, you can access it later, and you can apply completely different set of assertions on top of it to check, well, different conditions, if for whatever reason you decide to, well, check something else in future. And then what is also important is that assuming your tests failed and you don't know the reason, it's not only application logs that you have, it's not only well, all the metrics you would collect normally, but you actually have a recording that you can access that will help you to diagnose what was the reason of the failure. So you can always open the recording in a UI tool that is provided, and analyze what was happening inside your application with this tool. And this tool is Java Mission Control. So I guess some of you are already familiar with the tool because it's not new. It's in Java since version 7. Similarly to JFR, but then these were proprietary tools. And now Java Mission Control, as I mentioned, moved out of JDK. It's completely free. We are waiting for release 7.1. Its development is done, but it's in early access right now. And how you would usually use JMC? You would understand Java Mission Control as a UI tool. UI tool that allow you to control the recording on remote host, and then will provide you with the UI tools to visualize your data that were recorded. But this is not the only functionality of JMC. It actually has an API that provides you with an ability to do the headless analysis. And with this JMC tool, the difference is that it can actually access the recordings from earlier releases of Java back to version 7. So if you, for example, download early access of version 7 of JMC, you will see that you can analyze recordings of earlier versions of JDK, of earlier versions of JFR recordings from older JDKs. Why this is important? Well, mainly because an API is provided to you, and before there was no clean API, and especially open API to use to parse the recordings. So how do you do headless analysis with JMC? It's very similar to JFR. The only difference is, if you look at the slide, that well, you probably see a set of data types that are unknown to you, and this is mainly because it's all predefined inside JMC. These data types like filters, aggregators to build statistical analysis. There are attributes, type IDs with dictionaries of what you can find. So there is a learning curve if you decide to use JMC instead of pure JFR API. On the other hand, well, it's more strict as a language of analysis in compared to JFR. And it's not only this. What is the second well, important feature of JMC, starting from version 9 of Java, is an automated analysis. So you previously saw an example in JFR where I was showing how to analyze CPU utilization, and there was like a simple Java stream that was building up to summary statistics. But what it didn't took into consideration are edge scenarios, like your recording might have not recorded CPU at all, or it was too short to actually make any conclusions, right? And automated analysis in Java Mission Control will provide you with this edge scenarios analysis. It actually has a set of rules that are already predefined, and these rules define heuristics of, well, what you can what your application is doing. So let's like one of the example of the rules would be high CPU load. This would be a class where you will have a check on well, of edge scenarios, and in the end is going to check what was the percentage of CPU utilization, and then the result is going to be normalized. Sorry, this is not my laptop. And then the result is going to be normalized to the score between 0 to 100, and all the results from all the rules are actually going to be expressed. The output of the results is going to be expressed in terms of the score. And why this nice feature? Because you can start using Java Mission Control, Java Flight Recorder without any investment of your developer times. Like you can use it, you can start using it right now. You simply plug in the recordings, start the recording during testing, download the JFR file with a simple one-line code, and then apply these heuristics on top of the recording, and you will end up with it's a report that you want to control from code level, or these HTML reports that are generated also by the tool in current state. All right, so we see the tools that we have for us to utilize, to use, and let's move to use case. So how we decided to use all these tools that are available to improve our non-functional tests, our performance tests. What you see on the left side is very simplified architecture of the platform that we are building. And this is, as mentioned before, decision services platform. It's a distributed RESTful service. What is important about it, that this is a self-service to our clients. We, by definition, don't interfere much in terms of what our clients are doing with the platform and how they are using the platform. And it provides multi-tenant shared resources to execute decision models. So how you can think about it is we have a set of clients, each client being a technical team, and they come up to us with jars with some business logic inside. This is usually a static business logic. And then they will activate these jars on our infrastructure and they will start executing. So the risks that we have to handle with this are all the risks that can down our infrastructure. So basically, we have to be aware and have to be thoughtful in terms of what we allow to execute. But then, since we have over 200 different models being executed at the moment, and then the team is, well, small, we are not able to control everyone. And then we are, in addition to SDLC that we have supporting mainly the whole pipeline of how the model gets to the production, and in addition to functional contract that we have with our client, we have to think about non-functional contract. So we have to be aware of what our clients are actually going to execute and how this is going to affect our infrastructure. All right, so what did we build? We built a testing pipeline. What you see here is like in the top bar, there is a testing infrastructure. In the middle bar, there is an algorithm that I'm going to describe in a second. And in the bottom bar, there are report artifacts that we collect. So I mentioned that we have over 200 decision models executing at the moment. They are versioned, so our clients can, well, change the version anytime, uptick it, and start using the new one. We don't necessarily need to be aware of it, or we usually are not. So we try to intercept what our clients are executing in testing environments. And when we see something new being executed there, we will try to execute this testing pipeline for this particular decision model. So what we do is, in the first two steps, we will actually identify the model that we want to test. And then in the second step, what we will do is we will build a test set, functional test set. We are not going to check functionality. Test set of how we can execute the model. And how we do it, well, I said earlier, we have a functional contract with the clients. We also have audit store where we can take executions that clients are doing and then multiply them to large execution set. So since the decision model is a black box to us, we are doing it automatically. It's possible to do. So after the second step of the, we are going to end up with decision model that we have activated in our test environment, target environment, and a set of test scenarios that we want to execute against this model. And then what we will do is we are going to iteratively execute this decision model with different conditions, so different parameters of executions. We will start by trying to find out with what parameters we can maximize the throughput, because we are not aware of how model behaves, and we don't know what parameters will allow us to produce the maximum throughput. And then in the second set of iterations, we are going to test the behavior of the JVM when it is executing the model with different rates. So we will have a rate limiter, and each iteration is going to execute the model with different rate. And now each iteration is going to do following steps. It will identify the parameters of execution. It will start JFR recorder. It will start recording, execute the test, stop recording, and then we download the file locally. And then we have the file. What we do is apply a set of heuristics using JFR API you saw before. So we are checking whether, I don't know, we are checking if we are not connecting to network addresses that we didn't expect. Or we are checking that, well, there are no threads created that we wouldn't expect to be created. Or, I don't know, like GC consumption is where we want it to be. And then, in addition to these heuristics that we have defined, we would also create this automated analysis with JMC. So we will actually access the scores of the rules, and some of these scores we are going to interpret in an algorithm. In the end, what is the most important is that all JFR recordings end up in report scope. And in next step, after all the iterations, we will collect all JFR recordings. We are going to parse these files, and we will create an input to scikit-learn. So scikit-learn being a Python library for machine learning, we will build an input array with input features and output features that will allow us to build models of the behavior of decision model. And what you see here on the slide is the simple model that I decided to have it to present here. We actually don't have like very complex models. We can probably use different tools as well. We are using scikit because, well, in future maybe we'll extend this. But what you see here is a one feature array where the feature is requests per second, and the result is average CPU utilization. We currently have regression model built for CPU utilization, memory consumption, and some additional ones. But with each such input array coming from all the JFR, all the executions, we will create a regression model. Right now, we are assuming the model is linear based in terms of consumption, but then when we fit the model, we are in coefficients. So we want to know, well, how the execution of the model is going to affect resources that are available in the cluster. And then we obviously, after fitting, we check the score of an algorithm. We expect it to be above 0.9, which would mean that more or less we are dealing with the linear model. Right, but what we get out of this, right? What we get is for each decision model that is executed on the platform, we have coefficients that describe how it affects certain resources. So we know that if we apply 200 requests, we are going to end up with CPU utilization of this and this, or memory utilization of this and this. And then when we have more models executed in shared cluster, we can check with these functions whether what we would expect from the models is actually the reality. And then based on this, it can help us with capacity planning. All right, so in addition to this, we can also check, well, we have other benefits, right? So first of all, the most important is we can identify faulty decisions as they go into production. Clients are expected to start with a test environment where the model are going to be intercepted and go through the whole pipeline of testing. And then if they are faulty for whatever reason, we are going to catch it. The second benefit is that, well, shared cluster capacity can be controlled in more convenient manner. So it's always better to be aware of what is happening, having well, mathematical equations that describe the behavior of your model. But then there are two additional benefits coming from, well, regression approach to the results that we obtain. First of all, first of them is when we have client coming with a new of model, assuming they already have all the version described, well, tested with all the assertions with JFR, and then described in sense of the regression models. They can easily see where they are going with the model in terms of execution cost. The second regression benefit is when we actually release new version of decision services platform. Then what we have is we know how the previous version behaved for certain models, and we can check if our new version, with whatever changes we decided to release, is behaving similarly, or at least it's not causing any problems. And so, yeah, this is it. Let's move to questions, if you have any. Thank you.
What's the stability of your results? If you run the same code twice, how far the
Right. So yeah, there is a problem with, in general, there is a problem of repeatability of performance tests. Right now, we see that we can actually build linear models using several executions. If you look at this particular chart here, this for the presentation purposes, it was built out of 3 executions. So you see that the distribution is, well, close enough, right? But then we always have to take into consideration that the target environment cannot be fully isolated, and it execute different things during our testing. There are events in JFR that can help you identify if something is happening in addition to your application, and you can, you can define rules based on this events analysis that will tell you if the conditions on the nodes were different. We don't have those, but I've seen like events that will tell you what is happening outside of the application as well.
Do you warm up the test environment before the execution?
Sorry?
Do you warm up the test environment before the test execution?
Well, yeah, the application is running. The process instance is the same. It's warmed up and then it's iteratively executed with different parameters. Yeah, this is the case.
It's a stable one, right?
Yeah. Any other questions? Sorry.
Which tool you're using to create the load?
Oh, right, the load. This is very good question, because right now we are using our own tools. We are running it from, well, basically we are running it from JUnit test, and we have our own loaders. We were trying with different tools, but we don't have them used yet. Like if you take JMeter or Gatling was actually something that I was looking for a longer time, because this is a tool that already provides you with assertion syntax. And I was hoping that maybe I can extend it to plug in this, but then it turned out it's, well, at least from my perspective, it was really hard to extend it with anything. Like the assertions that they have, they are fairly fixed, and I wasn't able to extend it. So right now we have our own JUnit testing, and we have our own loaders. Yeah. Any more questions? All right. In this case, thank you very much.